Oh, streaming! Streams. Starting the streams. Alright. Let's see if everything works. Alright, this looks good. Stream is going. Hello, I don't think anyone's watching me. Oh, Sarian! I see you're the first! Sarian is the first. How have you been? So, right here is all I have so far. This is my new keyboard. So, kind of inspired by the other keyboard that I had made that I didn't build myself. This guy. This, if I can line it up right. This is a split keyboard. It's a Corn. There's the left-hand side. I've been playing around with this for 6 months now. I really love it. And I guess I'm just taking the next step, deciding to build my own. There's a lot to go over, but you kind of see the overview. I was inspired by Adam13531, now known as Adam Learns, and he made his own keyboard. He had his own keyboard journey video, and before I forget, let me get the link to this notebook page. So I've been doing pretty well. I'm very out of practice in streaming, so that's why this stream is all just going to be kind of how do you say, like making all the mistakes, getting back into the swing of things. So I've just been working full time. I did one stream where I was learning Go, but before that I wasn't really doing much other than admin to code back in December, right? Yes, this is going to be a rusty keyboard. So the firmware is going to be 100% in Rust. There's going to be some nominal amount of assembly, but from what I've been looking at so far, since I don't need to do this bare metal, because this microcontroller here, this is the KB2040 by Adafruit. It's sort of like a Raspberry Pi Pico put into a Pro Micro, is that it? Pro Micro or a Elite C form factor. There's quite a bit of crates already developed by the RP Pi group for the Raspberry Pi Pico, which this has on it, and so I probably won't need to do much assembly because all the foundational crates I'm going to be using are taking care of that. So yeah, my goal, continuing my journey in Rust, is to make a keyboard where the firmware is 100% in Rust. Yeah, it is a really nice little thing. Let's get a close-up of it. See if I can do this without breaking anything. And I need to put it in frame. There we go. See that little guy? He's teeny tiny. He's smaller than the... Smaller? Yeah, it's smaller than the... see, this is... I got to get all my mistakes out now. It's smaller than the USB-C connector next to it. So yeah. We're going to have fun with this guy. So I was hoping today to kind of, shake off the dust of my streaming setup, make sure that everything's working, so chat is working. Sarian, thank you for helping me with that. And get through all of the nervousness and kind of get my bearings, kind of see how this goes, introduce the project, and because I'm going to make this into a series, I'll probably want to put this up on YouTube when it's done. People are going to probably want to watch this from the beginning, maybe. I might make excerpts. So I have a couple ideas that... did I put them here yet? I don't think I did. But I put them in my Discord. So a couple ideas that I wanted to have, in addition to what I'm making here, is making this into a stream, because in the past it's always really helped me out to kind of go through my hobby work live on Twitch and getting that feedback and answering questions about it. I get a lot of really useful feedback from people. People are interested in what I'm doing. Sometimes people just want to be working or hanging out and just listening to my voice. Maybe I help put people to sleep. That's fine too. But I kind of enjoy the walking through the process of learning and building something and answering questions as I go along. So my thought is that as people ask questions, if they're the first to ask that question for the series, they will get added to the official list of questions and answers as being the first to ask the question. So, no one's asked a complete question yet, but we could say that Sarian asked Rusty. So we're going to put Sarian in. Let's see how this goes. I might try to automate this a little bit more in the future. So let's say the question is Rusty, as in, what about Rusty? Because that's going to be in the stream titles, right? And the answer is that most of the time, I'm going to be working on various aspects of the firmware, which I hope will be almost completely in Rust. Because I really love the Rust programming language. I don't get to use it at work, which is really convenient in that I can still use it in my hobby stuff and it doesn't intersect with work, which is a requirement. You didn't realize that was the stream title? It is the stream title. Commenting on not having done streaming for a while. See how like the puns, maybe the puns will keep flowing in this series. Wouldn't that be wonderful? So yeah, if anyone asks me about the title or anything like that, we'll see that Sarian asked first, and it's that we're going to be spending most of the time doing the firmware in Rust. So I do have some stretch goals. So let me not jump ahead. So overall, I showed off the fact that I already have a Korn keyboard. Looks like this, right? If I can get it in frame. So each side has 18 keys. I'm really kind of getting used to this. I'm using a Colmac Mod DH layout with this. So it doesn't have to be that. I could pick QWERTY, but right now I'm doing Colmac. So I'd like to make a keyboard that's somewhat like that. So that's the current design parameters is split keyboard, same kind of Korn layout. I might go back to having a 6th column here. I only have 5 right now. I want to keep the hot swappableness because I might switch out the switches. Right now I'm using brown switches, but I also have some samples of the white switches, which are the clicky kind. Hey there, Nightshade dude. And Dude Man, how are you doing? I know it's been a while. Hey, but this might not be a rare stream. As the stream title suggesting, I'd really like to get into doing regular streaming, and I have, late nights, early mornings EU time, late night Pacific time, some time slots, right? Monday, Wednesday, Friday. So I'm like, this is the stuff that I'm doing for my hobby. Why not do it live on stream? And I don't know, maybe people find it interesting that I am going to be figuring this out. I know some of it, and I don't know some of it. So part of this will be doing stuff I'm familiar with. Other things will be completely new to me, and it'll be fun. Hey there, SureShock. SureShock55. Did I say hi to everybody? I hope so. So this is going to be the truly rusty streaming that I'm rusty at streaming. So yeah, keeping this up. Yeah, I'm using the Keeb 2040. That's the Adafruit version of the Raspberry Pi Pico. Basically taking the microcontroller and then kind of putting it into a Pro Macro format. So just showing it off in the camera again. You can see it kind of looks the same dimensions as the Pro Micro. I can't do this with one hand, but like here's the Elite C that I have on my Korn. Let's see, do I have enough room here to put it side by side? Let's rest this right here maybe. If I put this side by side, you kind of get the idea that it's going to be the same form factor of the keyboard I already have. See that? The USB-C connectors roughly in the same spot. The two boards are roughly the same shape and size. Yeah, it's meant to... The Adafruit people meant it to be for keyboards. Kind of a drop-in replacement for the Pro Micro. So that's current thing. I have 2 more of them. This one is my 3rd, so it's sort of a burner. If I completely destroy it, I still have 2 others. Couple features of this are that it's got that USB-C interface. It's got a UF2 bootloader, which is kind of nifty in that if I hold down this button on the bottom, they're really teeny buttons. Hold that down and then toggle this top button. Did you hear that noise? So now I have another drive mounted. It is actually a mass storage device right now, and if I were to browse to that index.html, it gives you an intro, a link to an intro saying that this is using the UF2 bootloader, which means it shows up as a USB device, mass storage device, and if you copy a file that ends in .uf2 and it's in that UF2 file format, it will actually burn that into the flash for you. So it's really, really convenient. I'll be doing this a little bit. All I need to do after I build my firmware is to convert it to that UF2 format, copy it to that mass storage device, and then it will restart and run my code. My mouse isn't being captured. You guys can't see my mouse? Oh yeah, that's weird. That's weird. Why is that? That's really odd. I wonder if that's something that OBS is doing wrong. Well, this is going to be the stream where we make all the mistakes. Hey, Above Seagull. It probably doesn't matter too much because I'm hopefully not going to be using the mouse that much today. So yeah, back to this page here. We have the UF2 bootloader, which will be really handy. I really like it. I want to keep the TRRS cable. It's a really simple 4-wire interface, so we can pick SPI, we could pick I2C, we could pick our own custom protocol if we want, but basically bidirectional communication between the 2 halves of the split keyboard, and also having one side provide power to the other. But yeah, this is the really important point. Still into Rust big time, and I want to practice my Rust, and this is in the embedded sector, so it's going to be kind of fun. I want to keep at it. And I have looked at some of the alternative languages, but I don't know. I think I'm still bit by the Rust bug. You're 10 minutes from sleeping. That's fine. It's kind of hard to give a stream for both the US and the EU side, right? So this is the, yeah, exactly, no standard. This is the compromise. It's late night for me, early morning for EU. So we'll see the code in a bit. I'm giving a really long-winded intro. It's been like 13 minutes. But you'll see that we'll be doing some embedded Rust. Going core only, yes. But we can cheat and make an allocator. We just have to provide some RAM for it. So some stretch goals. I have this other board here. This is an Adafruit Feather. Can I do this? Can I line this up correctly? Yes. So now you can read it, right? It's the Feather. Bluetooth Feather. So it's got an RF shielded Bluetooth transceiver in there. So it's essentially the same as what I have, only it's got Bluetooth on it. So that's a stretch goal, is to use that instead, and then I'd have to buy 2 more to make an actual keyboard out of it. Then we can go completely wireless. I'd also like to be able to connect to either side of the keyboard. Right now, when I have this Corn, I connect to the left side. Here's the right side. The right side also has a USB connector, but if I connect that, the sides get reversed because the branch of QMK that I picked, it's not like fully reversible automatically. I kind of like to make mine so that it doesn't matter which side I connect to. It kind of figures things out. I'd like to be able to, when I flash one side, to have the other side automatically get flashed too. Right now with the Corn, I have to flash one, and then I got to flash the other, and it's sort of a pain. And then a companion graphical UI for, like, if I want to switch to, let's say, switch to QWERTY, or I want to switch to Colmac, but then try a variant of Colmac where, like, the inner keys are swapped around. There's Colmac, and there's Colmac mod DH, and there's a few others. So something that can conveniently switch keys around, or maybe switch keys on different layers. right now, with the corn, I have to go into QMK and change the layout in the code and rebuild and reflash, and it's a big ordeal. I'd also like to do 3D printed cases, maybe. So those are all stretch goals. I probably won't get to them. We'll see. So how are we doing? As long as VODs stick around. I think I still have my VODs on, and I will upload them to YouTube. So it's all good. And I might even make excerpts. We'll see. Yeah, the Bluetooth is a stretch goal. We'll keep that in mind. But yeah, you see around here I have some little things to play with. So I got one of these NeoKey 1x4s from Adafruit. So it's got 4 of those sockets already built in. Flip them over, you could take the switch and just pop it on. Like that. Hold on. I did this before the stream. Like that. So now I got a switch installed there. Could put a keycap right on there. Show you my ignorance and all that. There, now I got a keyboard. I got a 1-key keyboard. We're done, chat. Anyway, what I intend to do is, like, when we're working on the early firmware, I can wire that to this breadboard, and we can play around with like debouncing and key matrix and all that stuff. So without having to actually make a PCB, so that'll be handy. But later on in the series, I do plan to be doing some PCB work, and we'll have to have it sent out to be printed, and we'll come back and we'll be doing some soldering. It'll be a fun time. Done. Ship it, stream over. Exactly. Okay. Have I covered all the intro? I think I have. Shout out to Adam again, who really inspired me. He made his own keyboard. There's links there. And do I still have this in my clipboard? Yes, I do. So this is a link to my notebook again. Probably I will make a command for that, but I don't have it yet, to get to this, because I plan to put notes and other things and point people to that link to accompany the streams. Okay, so let me actually do some work now that I've gone through the intro. You guys know what I'm trying to do, kind of know the pieces I'm starting with. I can explain why it's blinking right now. So I went to the RPPi site, RP-RS site. So it's Rust on the RP series of microcontrollers. And it's a community of Rust developers who've made a whole bunch of crates. And I should probably make this bigger. How do I do that with my keyboard? It's Alt plus? No. I don't remember which key it is. We'll just do the UI here. There we go. Now everyone can read it. So there's a whole bunch of crates by the RP-RS folks, and one of them is the RP2040 project template. So it's a basic project that blinks an LED and designed for the Pi Pico. So I started with that and I modified it. So here's our first glimpse of what you have to do in Rust for doing firmware. And this is what was in chat before. Dude Man was saying, yeah, you have this global attribute no STD. And yeah, STDs are bad for this kind of work. But seriously, that just means no standard library. So we have no operating system. The standard libraries in most programming languages rely or are wrappers for, or both, on top of an operating system. So when you print, there's going to be an underlying console API of some sort, some kind of file system. There will be a networking layer, and so you have like a library. Part of the standard library would be to use the network to make sockets or connections. So we have none of that. No file system. We have no heap. We have no logging. So basically, our programs are much smaller, but we have very, very little to go on in the library code. Instead of the STD library, we have the core library, which you may have already, probably most people already know this who looked into Rust. If you look up things in Rust, let's do that now. Let's say we're looking up, I don't know, something that's in both would be like format. see there's a standard format. Let me make this a little bit bigger. Standard format's what you probably are used to using to like make a formatted string, right? Well, there's also the core equivalent of that. I guess there's no format in core, it's in alloc, but you see how for every standard thing there's a core equivalent? So that's the idea, is that everything in standard that doesn't really rely on operating system, there's a mirror of it in core. So we're going to be using that instead. Format isn't in core. Yeah, I know, it's alloc. I picked the wrong one. Probably, hold on. No box, Sag? No comprendo. Let's see. What would be in standard and core? I'm like drawing a blank right now. Besides format args. Something like, I don't know, ordering. There. So ordering is the result of a comparison between two things, right? So there's this familiar one in standard CMP, but there's also a core CMP. But if you look at something like file, there is no core file, capital F, because it's relying on a file system, which we don't have in core. So we can have file names, but we have no file system. So file names you'll find in core, but not the capital F, the file type for actual file system stuff. So yeah, anyway, I'm over explaining this. I'll get better at this as we go on. Your primitives are in core, yes. So option, exactly. Right. Thank you, Sarian, backing me up. Right, boxes, heaps, so we don't have that unless we pull in the alloc crate. So, what is no main? That means our entry point is not going to be the standard one that the dynamic loader will be jumping to, right? In fact, we have no dynamic loader. It's up to us to provide a loader. We're going to leverage the fact that some of the libraries we're using, like Cortex-MRT, provides the loader, so to speak, that calls our main, but it's not going to be through the traditional main function. The way it's done with Cortex-MRT, we pull in this entry parameter or attribute, and we mark up our a function with entry. It doesn't even need to be called main. It could be called not main, and it would still work. So not going into the details right now, but you can see it's not like your traditional program. You don't have to have a function called main. You can call you do have to have a function that will be encompassing all of the execution of your firmware, but it doesn't need to be called main. It also doesn't return. And instead of relying on the name main, we just have to mark it up some way or have some mechanism to jump into this function. So that's going to be taken care of for us by this Cortex-MRT crate and friends. We just need to mark up the function. So that goes along with this no main. So let's skip over all the uses for now. So all the LED blinking actually happens down here in this loop. So this is where the program is actually running right now. And we're going through an object to write out the colors for the LED, and we have another function to do the delay so that it's blinking through every half second, right? So let's go back and show you all the things that need to be done to get to having this interface to change the LED and then this delay. I guess we can work up from the bottom up. So delay is easier to understand. Delay is just a closure that I made here that given a number of milliseconds, we turn it into a, I think this milliseconds is just a wrapper to keep the units so that we can pass it to this start function, which takes something that can be converted into a time type. So it's just preserving the fact that it's represented in milliseconds and not microseconds or seconds or something like that. But this start is associated with a countdown object within the timer module of the embedded HAL. So that's a lot of things to go through. But basically there is a facility within the crates that I'm using that will use the peripherals within the microcontroller to measure time, and start tells it to sample. Ultimately, in the hardware, there's going to be a counter that increments once every interval. I think for this one, it's every microsecond. And we're basically saying, okay, sample the current time with the start. And basically become ready when the amount of time that we've said has elapsed since the point that's sampled. So that's what this wait does. So it's using like in the futures crate sense of like polling. So wait will either say, okay, we're done, or it would say this would block. And then we say, well, we definitely want to block on that. So we use a macro that basically does a loop until it actually no longer would block, right? So we break out when that wait call wouldn't block anymore. And while it's would block, we do nothing. Going back. Hey there, Endorn. A better start Tuesday with Mr. Ryan. Well, thank you, Endorn. So I'm trying to explain the code that's running on this microcontroller now, blinking this LED, without getting into too much detail, because it's like jumping into the deep end. And I only understand maybe half of it myself. So looking at this, you don't really need to understand all the detail down to the very bottom to get a sense for what it's doing. If you give it a number like 250, it's going to interpret that as a number of milliseconds and basically not return until that number of milliseconds has elapsed. And it's using some kind of delay object to accomplish that. All right. So working up one more level from that, this is the code that's getting us this WS interface. I think that WS stands for the, or it's short for the actual circuit name that's used to control that LED. It's a smart LED called a Neopixel, and WS2812 is the name for the circuit that is controlling that, basically a set of 3 LEDs, red, green, and blue. And we're using a driver for that, named after that same circuit. So that's why it's called WS, short for WS2812, the circuit for the Neopixel. And so what it needs to function is we need to give it access to the actual memory address that maps into the hardware peripheral for the pin that goes to that Neopixel, the data pin. So that's what this first parameter is. And then it needs a programmable I/O block within the microcontroller, and it needs a state machine associated with that programmable I/O block, and I'll get into that in a minute. And it needs to know what is the clock rate of all of the peripherals for the microcontroller, and it needs the same kind of thing that this delay thing needs, this countdown timer. So this programmable I/O and this state machine are the fact that this Neopixel has its own protocol, and it's kind of like I2C or what is it? Just think of it as I2C. And so we can't just send it the color RGB values and like you would at some higher level API. We need to actually toggle a hardware line up and down for each bit of a certain protocol layer that wraps around those values. And the protocol is designed with that WS2812. So that module knows what levels for how long to drive that signal to ones and zeros. And this programmable I/O is kind of like a DMA, like a direct memory access, like a hardware peripheral that automates the process of having that bit go to 1 and 0 back and forth at the right rates to signal those exact colors. So what's unique about this chip I found is that programmable I/O, this PIO device, has it's kind of like its own coprocessor inside. It has its own kind of a machine language, And the WS2012, if we look into it, it actually builds a program for that programmable I/O block and runs it in order to implement that protocol. Yeah, SPI, that's right, Endurin, Serial Peripheral Interface. So either I2C or SPI would work with this. I don't know what they use, though. Can you explain the differences between firmware and a driver? So firmware is sort of a nebulous term that can mean almost anything. Below the traditional software layer, when you get down to interfacing with actual hardware, so firmware could be the program that's run on this microprocessor, or it could be a program that's running in a digital signal processor that's loaded dynamically. It could sometimes firmware is even used to describe what's running on a GPU. I like to think of firmware as software that has access, like direct access to hardware registers, hardware map, memory map peripherals, that sort of thing. Whereas a driver is a little bit higher level than firmware most of the time. A driver is given an API to the hardware, but it can't get to the hardware directly. So usually a driver talks to some API, whether it's an operating system, kernel, or a hardware abstraction layer, which is what we're using here on the Raspberry Pi Pico KB2040 thing. And that hardware abstraction layer is implemented by firmware. So short answer would be a driver, high level, firmware, low level. But you could also call firmware the entire package program, including the drivers, that is burned into the flash chip on this board and has direct access to the hardware registers and peripherals. Oh, I'm sorry, Nightshade dude. Take it easy. Yeah, that's the data sheet. Thank you, Endurin. So, should we say that Tom Wheel has... Oh, and I never hit allow to that. Okay, there we go. The question didn't actually get through. By the way, Endurin, you could have helped. You could have pressed that button too. AutoMod blocked it for some reason. So there was the question. I'm wondering if I should add that question to the questions list. I think I will. I need to get used to this. So I'm gonna. This is something new I'm trying for my stream. In that, when people ask questions that might be asked again, I will put into the table and cite the first person who asked it. So question number 2 was from Tam Wheel, and that's let's just boil it down to what's the difference between firmware and drivers. And I'll just have the short answers. For firmware typically has direct access to hardware. That's like registers, peripherals, etc. While drivers may be at a higher level. Still lower level than an app, but separated from hardware by abstraction layers. And that's useful to remember, because when you think about it, the more variety of hardware that a driver can work on, the more useful that driver is. So being able to abstract away the hardware lets a driver work with more kinds of hardware. You just need to swap out the hardware abstraction layer, and your same driver will work with different hardware. That's why, for example, the standard keyboard driver in Windows or Linux or Mac OS can work with all sorts of different keyboards, because there is an abstraction layer, which is the USB class driver or class stuff. the class APIs, the USB bus on top of that. The driver doesn't actually talk to the keyboard directly through any kind of hardware memory mapped hardware addresses for the USB. It goes through an abstraction layer, which is the bus level, right? Anyway, sorry, I'm probably over explaining it. Go back to the code. I like Endoran's answer too. Driver is a high level API, the firmware is low level signaling. But you can also think of the firmware as more generally as the entire program that you burn into the flash or the file system, if you have one, on the chip, and that as a whole it has access to the hardware. Anyway, so this, I'm not going to go into terribly deep detail, but this just to recap, this WS object represents as a wrapper for all of the stuff that knows how to talk to the LED, which is a smart LED, a Neopixel. It needs access to the memory address that maps to the peripheral that can drive the pin that is connected to that Neopixel, the data pin, and it uses this programmable I/O block. It needs to know the clock rate, and it needs to have a timer function. All right, so going up from there, how we access the input and output pins on the hardware is through this pins object, which we use to get access to the pin connected to the Neopixel, and it's given access to what's called the peripheral access crate. Different pieces of information. I think this is literally the address. No, it's not. Okay. At some point, when you delve down to this, you'll get to the literal memory address where all of the peripherals memory mapped registers are accessible from the microprocessor, right? And so this pins class uses that to hand out objects that when you use them, either read or write those memory addresses, which access those pin peripherals. So it needs access to basically how it's mapped into memory, and I think these have to do with, again, that the state machine for the peripheral I/O, and then there's access to like how things get reset. Does that mean if there's a specific firmware for each hardware, then you have a different HAL? The goal is to get a driver which works with the most help. Well, usually a hardware abstraction layer, a HAL, has the same API going upwards to your drivers, but you'd have a different implementation going down to each different piece of hardware. Another way you can think of it is for every piece of hardware, you'd have a different implementation of that same HAL, and that HAL has the same interface going up. So you, given a piece of hardware, you pick the corresponding HAL implementation that goes with it, and then the driver should work with that HAL because the HALs have the same API. So like if we look into the crates that I was looking at, this embedded HAL provides types for things like, where is it? Or is it? These traits. Yeah, here's a good one. The serial interface trait, right? So if this at the HAL layer, if this is the interface a driver would use to talk to a serial port, all that the driver needs to know is you can call this function to read a byte from the serial port. You can call this function to write a byte to the serial port. Now, lots of different microprocessor, or not microprocessor, a lot of different boards would have a serial port on them, right? You could have one driver that knows what to do with the serial port and just pair it with different HALs, one for each board, and the same driver would work for all of them. Yeah, hardware abstraction layer. And Doran asked it first. I'll get quicker at this as I go, but I want to write these down. Come on, open up. So bear with me. Thank you for your patience as I get faster at this, and I might change my process because this is feeling kind of slow. What is a HAL? hardware abstraction layer. So it defines a common interface that will be implemented differently for different actual hardware configurations. The key is that there's a common interface. Again, a driver can use the common interface and then work with different kinds of hardware just by swapping out the implementation of the HAL. All right. So I didn't explain this very well. I don't understand this completely, but suffice to say, this pins gets access to the actual pins on the hardware. One of them goes to the Neopixel. Okay, and then here's where this delay comes from that we used way down here. So this delay is just some wrapper for this timer, and this timer has access to the actual hardware timer in the chip, which we have access to through the peripheral access crate. Okay, and then I think this init clocks and PLLs is just the way that the Cortex M crate that the RP-RS group made. It's just their standard way of initializing firmware when you first start up. Is that you one of the first things you do when you start up any kind of hardware is you have to start all the clocks, and PLL is a phase lock loop, and it sort of goes along with the clock. It's how you regulate a clock frequency and how you generate other clocks from a master clock. Clocks are very important in hardware. They drive your state machines. They run the microprocessors, various loops, and there are lots of them for different frequencies for different reasons. Ultimately, there's a crystal oscillator somewhere in that board. It has a certain set frequency. It's usually something like 48 megahertz or something like that. And you'll use a PLL to generate a faster clock, or you might just use a simple divider to make a slower clock, right? Anyway, so this init clocks and PLLs is setting up all of the peripherals that take that crystal oscillator and derive all of the clocks that we need from it. It can depend on the MCU. The AVRs don't need you to initialize the clocks. Might be ceramic oscillator for cheaper boards. You mean I don't actually have a real crystal in there? Yeah. One interesting side experiment might be try to figure out how good the crystal oscillator in this thing is just by having it use some kind of thing like network time protocol to measure how much our sense of time drifts forward and backward versus the atomic clocks that are around the internet, right? We can get a measure of how good our clock is just by seeing how it compares. So let's see. This being the first thing that we do, setting up the clocks. To do that, we just need to get access to this peripheral access crate, and I think this is a singleton that represents at the lowest level just physical access to everything. Okay. So let me show you the process of like how we would compile this code and burn it into here. Let's say instead of white, I want to make it, how about just make it green? So that would be turning this to a 0 and turning that to a 0. Actually, I can leave this to a 0 too. So this is the color of the LED. So that would be green, and this would be black, which basically is off. And then there's this brightness wrapper around it, which basically takes the color and tunes it down to a certain brightness. So instead of 32, if I put 8 there, it would be a quarter of the dimness. Oops. A quarter of the brightness, or dimmer. The fact that we have an iterator here once is because this smart LED, typically you chain them together in a daisy chain, like an LED light strip. And so if you had more than one, your iterator would have more than one output. In this case, we only have one LED, so we only use it once. I think the KB2040 does use a crystal, kind of like a crystal package. The thing is really cheap, and crystals are pretty good these days. They're not necessarily expensive, right? So yeah, we changed that to green. Now, we'll do the traditional thing in Rust, which is to do cargo build. One thing I'm going to add on to this is release. I wish I could make this the default, but as we all know in Rust, the default is a debug build, which is useless to us because I don't have a debugger. So might as well make it optimized, right? So what this does, if I do a dir target, our target is thumb v6m none EABI. That means thumb v6m is a combination of things. It's using the ARM thumb instruction set, which is 2 bytes per instruction. V6, I think that's the version of the ARM thumb instruction set, and the M stands for Cortex-M, which is a variant of the ARM product line for mobile. All right. The none stands for the fact that we have no operating system. EABI, I think it's just an identifier for standard application binary interface, and I don't forget what the E stands for, but so the combination here is the processor, operating system, and application binary interface, like the calling conventions. So ARM thumb, no OS, and standard EABI together describes everything we need to know to describe this target. And then release beep beep. Sorry. When you hear beep beep, that's because I changed the Windows bell so that you know it's not your computer you're hearing, it's mine. So this, even though it doesn't give it a file extension, it's in .elf format, ELF. So it's a binary intended to be loaded onto a firmware binary intended to be loaded as a boot image to a microprocessor. So I said before, this thing comes with a special bootloader that uses the UF2 bootloader standard that Microsoft developed, and there's a tool called ELF to UF2 ported to Rust. That's RS. And then I just need to give it the path to that, so I'm going to cheat and copy paste this and auto-complete that. So now when I do the directory, there's that UF2 there, and the date shows that we just built it. So that, I just need to copy that UF2. I need to copy that onto the device. And if you missed it before, it's a little bit weird. This thing has a bootloader which makes the device look like a mass storage device. All I need to do is hold down the bootloader button and reset the thing. There RW Grim. I'm about to flash this device. So when it's in bootloader mode, it's a mass storage device, and if you copy a UF2 file to it, it triggers the flasher to is it called flasher? It triggers the programmer to burn your code into the flash. Automatically reboots, and check it out, it's green now. So super convenient. I think I want to actually take this and put it into a batch file or script, so I don't have to type that out or copy paste it. But yeah, that's the whole process. We can just change the color again. Let's make it red this time. Maybe reduce the brightness because my camera kind of makes it all hard to see. So it's just cargo build release, and then ELF to UF2 RS it, and then copy to the drive, but I have to hold down the bootloader button and then toggle reset. And then I can program. Now it's red. Doesn't come across on my camera very well, but believe me, it's red. See that? All right. So thanks for the raid, RW Grim. How's your stream? This is my first stream in a while, so I'm going to be making plenty of mistakes, and I'm going to be looking really like a scuffed streamer, but that's okay. I'm starting this new project that is building my own keyboard, and what you see on the second camera, this is what I have so far. So here's my basically the project overview, and let me get a link to this actually first. For anyone who cares to look at it right now or later, since I'm going to keep this up to date, and I'll make a link for this later. I was inspired by Adam13531, who made his own keyboard, to jump into this and make my own keyboard as well. The spin I'm putting onto it is we're going to write all the keyboard firmware in Rust, and I'm going to do it all on stream if I can. Isn't that loop entirely fast, that it uses CPU a lot? Yeah, I'm going to look into that because I would like to know, deep inside this block here, this loop is going to hit this do nothing over and over again, literally millions of times. Aren't we wasting power, right? I don't know. I was, before starting with this KB2040 microcontroller board, I was working with the Raspberry Pi Zero, and it actually has a special coprocessor instruction called wait for interrupt, where it puts your CPU into a low power state until an interrupt happens. And I thought, I wonder if that saves power, but I have not actually measured it one way or the other, so I don't know. Do you have a scheduler you can yield to? That's what I was doing with the Raspberry Pi Zero. Is I set up a scheduler, a timer would trigger an interrupt after a certain interval elapsed, and then I would just run the wait for interrupt coprocessor instruction, and CPU would sleep until that interrupt happened. We might have the same thing with this Cortex-M, this KB2040, or basically the Raspberry Pi Pico. We might have that, but I don't know yet. That said, even if we don't have like a low power state that we can go to waiting for an interrupt to happen based on a timer that a scheduler would use, we might not care, because I think the power that this microprocessor consumes is so small, it probably doesn't even make a difference if it busy loops or not. I bought this USB power measurement thing. I have it behind me. I'll have to get it up for the next stream. But I was trying to measure the power that this thing consumes. It's so small, it says 0 most of the time, but once in a while it'll blip up to 20 milliamps. So I was thinking, with that little power draw, you could probably run this on one of those coin-sized batteries, and it won't matter if you busy loop or not, because the thing just draws so little power. But it is an interesting question, and I would like to measure it. I need more high precision measuring equipment for this thing, because this power draw is so small right now. I'm just thinking, should I make those into questions? And where's my alt tab? There it is. I think I will. I'm trying to do this for the stream now, and I'm going to get faster and faster at this, but you'll have to bear with me right now as I'm slow. So, we had 2 more questions, right? So, SureShock55 asked, with loop, doesn't that use the CPU a lot? It's probably a better way to phrase that question, and my answer is yes. But it's possible that the power use with a busy loop versus some kind of sleep mode is so negligible. Spell it right? That we won't care. Still, we should try to measure it. All right. Bear with me as I answer the question. Lol, is this Rust then? Yep. It is Rust. This is definitely Rust. The difference between normal Rust program and an embedded Rust is that you scroll to the top. If you ever see this, you're probably in an embedded environment. We have no standard library, no operating system. We're on our own, basically, unless we pull in libraries that friendly people on the internet have written to help us. RP2040 datasheet has a graph of power usage versus frequency while doing FFT calculations. About 125 megahertz, doing about 25 milliamps is so small. Most people actually use more current than that to drive an LED. So, autocorrect says it's right, yeah. Never used Rust this way? Yeah, it's fun. I was playing around with the Raspberry Pi Zero, and I didn't even have any libraries. It was bare metal, and you have to do a few more hoops. And I'm planning to make a YouTube series about that, but there are parts of the way you use Rust are the same, and parts are different. It's really interesting. Okay, the other question I wanted to write down that I think, Quantum Apprentice, by the way, thank you for the raid. What happens if you panic and embed? Oh, I need to write that one down too. Okay, so we have more questions. I'm probably going to fall behind. I don't want to miss these questions though. Question 5 that I wanted to write down was, do you have a scheduler? This is actually from Rainy Day Tomorrow. Asked 2 questions. Whoop, that was supposed to be an unders bar. Actually, I'm just going to copy paste this because your question was phrased just right. Do you have a scheduler that you can yield to? I don't know yet. Well, yet. We do have a scheduler. We do have timers, but it looks like the RP-RS people have implemented it to just busy wait and pull a hardware timer. Because I interpreted the yield to mean that it goes to sleep, or it basically doesn't busy wait and pull, and we might have such a facility using interrupts and the hardware timer, but it doesn't look like the RPRS people are using it. But so I don't know yet. We might have, we might not. Don't know yet. Rainy Day Tomorrow also asked. What happens if you... So I'll answer this one now as I type this. What happens if you panic and embed it? It depends on your panic strategy. So there are 2 panic strategies I'm aware of in Rust. The default is to unwind, which means that every stack frame that's in your call stack gets unwound, so everything that you created on the stack gets destroyed until it gets all the way to the top, and then the top of your program decides how to handle that, like a panic handler decides what to do. Like, do we just run the program again? Do we re-enter it somehow? Or do we reset? For the no standard, so the embedded environment, it's up to us to provide a panic handler, so I think by default, the panic handler that's provided by the RPRS people just prints panic and then busy loops. I'll probably do the same. But you can pick an alternate panic strategy. The one that I've used in another thing I was tinkering with is the abort panic strategy, where you just say, screw it, we're not going to bother trying to unwind this thing. We're not going to run any destructors for anything on the stack. We're just going to like give up right now, right? The simplest thing is just say, sorry, and then busy wait or go to sleep forever, right? So it does depend on the panic strategy. You set the panic strategy when you build your code. And let's see how this template, if they actually bothered to set that up. Sometimes it's set up in Cargo TOML, but I don't see it here. There would be a section called profile, and you'd say panic equals something like abort. So it must be using either the default or it's set by the Cortex M crates to something else. Yeah, we didn't even have to set up a panic handler. I think it's taken care of for us. How far am I falling behind in chat? Hey there, Filcher. Morning, Romania. Hey. The better panic strategy might be to reset, but then you run the risk of a panic loop where every time it boots up, it panics, and then it boots up, and it panics, and forever. You could do some trick like write to some non-volatile storage the fact that you're about to panic, and then if you reach that point again and you haven't booted correctly and you panic again, maybe you switch to doing something else rather than rebooting. Don't want your keyboard locking up. So another alternative would be you might go to DFU, so device firmware update mode, where you just say, hey, I need new firmware because I can't boot up without panicking. But if the panic is some fluke, some bug that we have, reset might be a perfectly good choice, because if it's infrequent, you would have it reset, and then maybe right before resetting, you'd write into non-volatile storage the fact that you panicked and maybe where you were, and then when it resets, maybe it would you'd have some way with your computer to query the keyboard and say, oh, the keyboard crashed. Here's the panic report. You know, maybe you might want to debug that, but I'll continue to work until in the meantime, right? We have a reset button on this thing anyway, so even if it locks up, I can manually reset it. You have some LEDs that take about 10 milliamps just to light it. These little ones take very little power. They're not even registering with the power meter that I had. Did I miss any good questions? I don't think so. I think, lol, is this rest then? I think the answer to that is yes. All right. What I wanted to accomplish today is, in addition to everything I've done so far, is I want to actually start the project so that everyone who's watching now will be in on it from the beginning. 2 milliamp LEDs, but they're 0603. So these ones in here are 0505s. So they're 0.5 millimeters square. Oh, no problem, rainy day tomorrow. That's part of the reason I'm streaming. If I wasn't streaming this, I would be doing this without talking, and it would be just for me, for my hobby work. The only reason I'm streaming, well, there's only really two reasons I'm streaming this, is that I enjoy interacting with the community, and that you guys help me in return with your questions and your advice. Is it 0505 or is it 5050? I don't know the nomenclature, but it's obviously less than a millimeter. I think it's half a millimeter. Haven't seen that package? Just look up Neopixel. I could probably find it. Uh, 5050? Yes. This one. So they're really teeny. Okay, it says 5 millimeter by 5 millimeter, but I have a hard time believing that. It looks smaller than that. I thought that might be a typo. It can't be 5 millimeter by 5 millimeter. That's too big. It's much smaller than that. Maybe they're talking about the outer package, but when it's integrated on this board, there's no outer package. It's just the inner LED stuff, so it's smaller than that. Okay, so yeah, what I want to do is start the new project. So we're going back out here, and I'm going to do cargo, new. And now we need a name for my keyboard project. We can call it Rusty Keyboard. Because I love original names. Okay, so let's see the... Actually, let's just open a new... Excuse me. Open up a new window. And I will open a folder. And I'll go into here and pick Rusty Keyboard. Did it not take? It didn't take. Okay. Nope, it just took a while. All right. So then we'll full screen that guy. Okay, so we're starting here with a bare bones Rust project, which says hello world. Let's change it to say, declare right away that, whoop, that was my clipboard. No standard. Right away we're going to have a problem, right? No printf anymore. No print lines. Okay. I think, yeah, let's pull in the no main as well. Now it's like, okay, who's going to call the main, right? We're going to need this we're going to need this entry function. Yep, I'm making a keyboard set who. Here's what I have so far. I have the controller. And I have a little collection of parts that we're going to play with while working on the firmware. Love how the datasheet gives you dimension, not the units. Yeah, maybe I'll measure that for myself. It's teeny tiny though. It's very low power. Nice time to write out your own print line? I don't think so. There's write, right? This is what we'll probably end up doing in the end. Either write or use one of the logger facades for that. We'll write out to some device, some log, right? Which will be the equivalent of that. Might be 50 mil. 100 mils, so I'm not even familiar with those units. Okay, so I think I'm gonna largely just steal from their template. They won't mind, right? The RPRS people won't mind that I steal from their template. That looks like boilerplate to me, along with setting up the clocks. That's boilerplate, right? Oh, the other thing I want to do... I forgot, can I drag files? I would like my editor config. Oh yeah, that does work. Sweet. I want my editor config and my Rust format files. And... I'm going to want this memory.x, and I'll explain what that is in a little bit. Do I need this config toml? Yeah, I will need that. But I'm going to just copy from that. I'll get to that in a minute. All right, so... there we go. Back to main. Yeah, this is more boilerplate here. More boilerplate. Let's comment this though, and this is make a delay wrapper from the system timer that we can use to basically sleep. Busy wait. Well, let's not even assume we're busy waiting. Let's say we can use to block until... actually, the blocking is done... Fighting with my keyboard, sorry. This is why I'm making a keyboard, because I fight with my current one. We're going to use the delay with NB block to make a blocking delay thing. So this delay is really a wrapper that we can use to track time. That's what I should say. That we can use to track the passing of time. All right. And yeah, let's copy this, but I'm going to annotate that. I'm going to remove the infos because I don't think we need that right now. And I should copy my little... Did I copy that? All right. Now we got to resolve all of the errors. Bad. Yeah, I know. I'm kind of forced to copy a lot of this boilerplate because this is how the abstraction layers that the RPRS folks made expect you to use their stuff. It's in all the examples, right? So ultimately, we need to take the peripherals from the peripheral access crate. Actually, we don't necessarily need a watchdog. No, we don't need a watchdog, but their init clocks and PLLs needs the watchdog. So we need to get it. It's like we need to call this, and it expects to get these things. So we need to get those too. So all together, this is like stuff we're expected to do. I almost kind of want to put it into a function called boilerplate and get out of it only the things that we really need. So the only things that we really need, I forgot. Well, basically, we need access to that LED, and we need access to be able to this delay thing, so we can measure time, right? So I kind of feel like that's what we should have a function called boilerplate. Specifically, this is HAL boilerplate, right? And we get back from it. Maybe keep it into a tuple right now. I still haven't decided if I would call it a tuple or tuple. But we want our WS2812, and we want our, I don't know what the type is. Let's see what the type is of this delay thing. It is a countdown. We want a countdown object. All right, so let's move all our boilerplate in there, just to make it clear that it really is boilerplate. Yoink and splat. Okay, and then we'll just return return the resources we actually care about. In our firmware. And right now, that is WS and the delay. And I forgot to copy over the WS constructor, right? That's this one. Does it matter where I call it? I did it after the pins thing. I did it right here. There we go. Quadruple is oople. Quintuple is upple. Take your pick. I know. Can't decide. Okay, we have lots of things that we need to fix. Okay. We're gonna get these from other crates. So let's find those crates. So the WS is this WS2812 PIO. The smart LEDs defines the interface that this thing uses, and I think it's not included for us. So that's why I had... Let's see if I can get away with not specifying that as a dependency. I probably won't be able to get away with it, but let's see. Copy, paste, and then I should be able to... it's analyzing. Hurry up. Rust analyzer taking forever. Actually, while it's working, I know I'm going to need to have that our own cargo toml and a build RS file, so maybe I should get those set up. What our cargo/config toml does for us is we need to customize what target we're building for. Otherwise, it's going to build for my Windows computer, which doesn't make sense, right? We want to build for this thing, not my Windows computer. Now, for that target to be buildable, we need to have that toolchain installed. I've already done that. If you're starting this out fresh, you would actually need to install that target with Rust up. I kind of skipped that step. In addition to selecting that target, we customize the Rust flags to do certain things. Their example uses a custom linker. I don't think I need to pull that in just yet. We need this linker argument because it's required of us by the HAL crate that we're going to be using. That's how they set up all the bootloader part of the firmware, where the stuff that calls our entry point. Somewhere in their documentation they say you have to have this Rust flag, so we need that. I don't remember what that's for, so I'm going to try doing without that. And this is just optimization stuff. I'm going to leave that out, and we don't need that. So I need minimally that Rust flag and that build target. So I think, yeah, I'm just going to set up right now a .cargo, and in there a cargo, was it config.toml? See how good my memory is. Did I get it? I did. All right. We know we need that verbatim. All right. And I need some of these Rust flags. Let's just copy that because it's easier that way. Oop. And paste here. And we'll get rid of this special linker. We don't need that. I don't think I need the end magic. I don't think we need that. And we definitely don't need this stuff. We definitely need that one, though. I think that's minimally what we can get away with. Let's try that. Okay, so we can import that one. So we got one import resolved. Well, to find out where I think countdown is from one of from the HAL crate, right? Let's find out. Where is it? This thing, right? It's from the RP2040 HAL. So let's pull that in. Where do they pull it in? They don't pull it in directly, I guess. Okay. This is our top level, like, board support package or hardware abstraction layer, or whatever you want to call it. It's the one that's tied to this specific board. So we definitely need that. So let's put that in now. And I think it might pull in the other HALs, but we'll find out for sure in a second. But we're done with these. Okay. Clippy is a little bit slow because I pulled the rug out from under it by changing the target on it and adding that dependency, so I need to wait. Okay, is it ready yet? No, it's not ready. Can't find crate for test. I can't remember why we would get that. Hold on. That, I didn't expect to run into that. Does that have to do with something else in cargo toml here? I don't think we need any of these things, right? These are just like optimizations. Maybe we need that to change some of these things? I don't remember. Oh, right. I think this is what we need, right? We need Resolver 2 in our package. I don't remember exactly why, but I looked this up before. Whoops. I think that solves this problem. Yes. No. Okay, well, when in doubt, we Google things, right? So let me look that up. What DuckDuckGo? We'll DuckDuckGo it. just like to, I'm doing this because I kind of just want to understand why it's doing this. There's no test crate for the ARM target. Right, so we need to somehow tell it that there is no test. Like, don't build a unit test. Don't build a test configuration. I forget how we did that. Okay, this is not giving me any answers, so I'm going to go back. So I'm not the first person to run into this. Probably the same as that. Aha. Oh, right. That's what it was. We have to tell Rust Analyzer not to check on all targets. And they did that through a VS Code setting, this one here. Right, so we need that. Well, we might as well pull on all of these things, right? These are all good things to have in VS Code settings, so let's do it. Let's make a .vs code settings.json, if I could type, and paste that. So we're saying that our target is that. We might not even need that one. This is the important one because we're saying we're not building for all targets, we're just building for our thumb target. And actually, I don't even need that because I have that built into my global settings, so I'm going to delete that one. Do I need to restart Rust Analyzer? I probably do. Let's restart. Hey there, Audrey31, how are you doing? Okay, we got rid of that error. Add missing generics. Now what's the actual problem? Oh, right, it does need generics. So, can I just say impl then? Quick fixes are always good, right? It's going to need me to define those, aren't they? Okay, this sucks. How do we get away with that in the other example? Oh, it has a specific type. Can I just cheat and copy that then? Let's cheat and copy that. Okay, we'll just need to pull in those symbols, but first things first, I wanted to bring countdown in. Okay, cool. So that comes from the HAL. Why is it still a problem? Missing a lifetime specifier. Okay, sure. It's static. Lovely. These are probably also things I can quick fix, right? Yep, let's do it. Quick fixes are always best. This one, static lifetime. All right, peripheral access crate. Import that. These are just need to be imported. So I'm just doing the quick and easy thing. Import them all. And it clocks in. So these are all coming from the HAL, which is good. Means I don't need to specify any other dependencies manually. Same thing with timer, right? Yep. And pins. Yes. Easy way to handle that. Replace all those generic types with empty and see what the compiler says, or look at the example. Yeah, that's true. Easy. What's the problem, Audrey31? What's the real big problem? Okay, this one, it's a trait that we're pulling in, and I hate pulling them in named. I always like to pull them in unnamed, because we only need it for the trait. Clock. Is that, again, something we don't need the name? All right. Entry. It didn't like that. Okay, failed result. Could not find Cortex M-RT in the list of imported crates. So I need to import it explicitly, probably, right? Is that what their example did? Either with extern crate or through cargo toml, right? Yeah, so I hate specifying the .0 part. So I'm just going to copy that dependency without the .0 part. Like that. What's the error now? It must have the signature unsafe function. Why? Let's remove that import for a second. Let me restart the server too. Critical vulnerability issues in Androids and Apples. Well, good thing I don't have an Android or an Apple. This is a Raspberry Pi. Okay. I need to find out where does that entry attribute actually come from? It comes from Cortex M-RT macros. Okay, this is how they're pulling it in, so I should probably do the same thing. Sometimes the imports are weird. Oh, right. We do have to say that it never returns. Okay. That's what it was. Alright, we're almost there. Okay, did I forget to pull in my... I forgot to pull in the boilerplate, so... do the HAL boilerplate. Do is a bad verb. How about... What's a good word here? What if I just don't say do? Just say HAL boilerplate. And we say, let our WS and our delay, which are the only things we care about, equal... I called it HAL boilerplate? Yeah. HAL boilerplate. Cool. Okay, why does it... how come I'm not getting any code actions? Do I need to restart the server again? Rust Analyzer having trouble? Maybe these types aren't completely known? Generate, create? Usually I just hover over it and says, oh, you can just import something. Yeah, no quick fixes available is not what I like to see. There's no... Okay, here we go. It's available from there. It's just the trait is not in scope. So I need the countdown trait in scope. It is in scope. Why does it not think it's in scope? That's what I did, didn't I? I don't get it. Alright, I don't get it. Is the problem that the time... Okay, there might be a problem in that this timer, we need to return that back out or something, because this counter here has a lifetime. What is it? It has the same... It uses the timer. It's of the lifetime of the timer, right? Yeah. So it's borrowing the timer. So the countdown is only good for however long it can borrow the timer. So we need to fix this because this timer is going to be destroyed when we leave this function. I suppose I can return the timer too. So it's not static. Or I can handle this boilerplate later. let's do this. Let's do this later. I want to have the boilerplate tucked away somewhere, but because this is becoming more difficult than I expected, I'm gonna punt and do it later. So I'll just basically copy this out right now and put it here. Get rid of the boilerplate function. Okay. It's weird. It that didn't fix the problem. Okay, this I can pull in. As underscore. Embedded time. Embedded time. So I guess we need that. So we're just pulling in what we basically discover that we need until we get rid of all the errors. It still doesn't like this. I thought we had that. Perhaps add a use. We already have that here, right? Maybe it's how. Oh, right. Countdown is from the wrong. It's from the wrong module. Okay, that's the problem. Delete that. Okay. Might as well delete these things we don't need right now. These were only because, actually that I messed up. Those were only needed because I was explicit about that generic. Now I'm no longer generic, explicit about it. Embedded HAL, we don't have embedded HAL yet. So we need that, including the unproven features, I suppose. Actually, let's see if we can get away without the unproven features. So let's do this for now. The last version of 0.2 would be fine. Until it tells me I need an unproven feature, I'm going to not ask for it. This was working before, right? No method name frequency for that structure. The traits aren't in scope. Okay, so we need this trait in scope. Ah, that key. There we go. How did that happen? Wait. What did I do here? What's it doing? Oh, I see what it's doing. That doesn't need to be there. What's this error mean? Unresolved import. Can't find our... What? Okay, can't we just include that directly then? Use that. We don't even need it named, right? Fighting my editor, sorry. Is that... Okay, so we need that import also then? This one didn't need it though. Okay, so... Let me look at this one's main. Deleted the clock import, did I? Oh, so it's under how... But that was the wrong place for it to import, wasn't it? Okay, maybe that's it. So yes, I guess that auto import sometimes gets it wrong. Sure, we'll chalk it up to the help sometimes being wrong. Okay, yeah, that's what it was. Thank you, Sarah Yen. It publicly renames it. Okay, so yeah, the auto import whatever betrayed me because of the rename, I guess. All right, now we're down to NB. Now that I know is from a crate we didn't pull in yet. That's this NB crate. We need that. So this is the non-blocking crate. It's just a convenience crate, so it provides this macro, which we looked at earlier, which I can't click on yet, but when I can, there we go. It's providing a convenient macro that just loops until something will no longer block, right? When it doesn't, it's no longer returning a would block error, then it breaks out and just loops while it would block. So that's all that, whoops, that's all that crate is really doing for us, is turning, is doing a busy wait for us. Okay. Okay. We need, okay, we do need the smart LEDs trait. So there's two problems, right? If we do pull that in, we'll need to pull in the crate that goes with it. So it's going to say that crate doesn't exist. So let's pull that in the smart LEDs. New phone, who dis? Phone? No, this is keyboard, not phone. Or are you talking about your new phone? And who dis Raimu? Did this need to be restarted? And that auto use thing might have betrayed me again. Yeah, I think it's smart LEDs. It's a rename again, right? That's what it actually should be. And we don't need the name. So we cast away the name with an as underscore. Almost done. So we need brightness. Where does that come from? Quick fix tells us it's from smart LEDs. Once is from iter. From core this time. And then RGB 8 is from smart LEDs. Oh, I think we got rid of all our errors. Let's get rid of that. So I might actually get this firmware running. Let's pick a different color to make sure it's actually doing the right thing. What color would look nice? Maybe a purple? So red and blue? Right now it's flashing red. See? It's red. So if I do this right, it'll be... And let's make it blink faster. Blinking intensifies. Just to make sure, to distinguish between the old firmware and the new, to make sure we're actually building the firmware correctly. So cargo... build release. Hey there, Clayman. How are you doing? We're making keyboard firmware in Rust. Actually, we're just establishing the project right now. Once we have a working firmware, then I can start tinkering with it to do whatever aspect of this project I want. Like I could work on key debouncing first, or I could work on the what is it, the TRRS connector first. Any of that stuff I can do first. Basically, I'm trying to establish the platform we can tinker with right now. All right, panic handler, not found. I need to figure that out. I think that is pulled in by one of the HAL crates. And I guess we just need to pull it in and not actually reference it at all. Which one do you think? Which one do I think it would be? Oh, it might be in here. one of these things that I dropped, right? Because in our version of our configuration, I put it to the bare minimum. Maybe there's something here I actually need. I mean, I can pull this back in and see what that does. And that thing, maybe? We pull these 3 lines in. I'm pretty sure I don't need that custom linker. That was like an optimization. Let's see if that gets us anywhere. Nope. Okay, that's not it. Okay, just to verify, this one doesn't actually have a panic handler, right? Anywhere. It does have this. What does this do? Oh, that's a panic handler. Okay, so... Oh, okay, so their template pulled in a panic handler that worked with this probe run program. You know what? I don't think I need this. What if we just make our own panic handler? So here's their panic handler, right? Essentially, we just need a function that gets called if we ever panic. Let me just make one. Let's put it in a module called panic that will pull in from our main, right? So mod panic. It's good to have separation of concerns, right? So our panic handler will just loop forever. Panic info comes from core panic info. And we don't need to use the info, so put an underscore in front of it. All right, now will it build? Hey, it built. Okay, now I don't want to keep typing this in every time. I had it here, right? This is the one that converts the build into the UF2 format. Let me copy paste that. Let me make a new like a batch file because I'm on Windows because I'm crazy. We'll call it flash.bat. All right, so ours is named Rusty Keyboard. Okay, that was one command, and then the other command was to copy it to the mass storage device when we're in the bootloader mode. So, again, it's rusty keyboard.uf2. There. So now if I put into bootloader mode, which is hold down the bootloader button, and then toggle reset. Alright, it's in bootloader mode. Now can I just run flash? Memory segment is outside valid address range for device. Okay. That has to do with this linker stuff. So we have this memory.x, which specifies the memory layout, but I think that needs to be included by one of the linker options, and it must not be link.x. It must be that other one. Maybe this def format? Let's try this one. So build it again. Flash. No, that's still a problem. Okay. It's not building with the right memory map yet. What am I missing here? Do I need this one? Maybe that's what I need. I'm kind of guessing here. I could look this stuff up, but I'm really not too much interested in this really low-level stuff right now. That's not it. It's not... These are code size optimizations like it says, right? We have all 3 of these. This is the custom linker. Do we really need that, though? Is there something else I'm missing here? No, that's just via Rust Analyzer settings. Oh, build RS. We're missing this one. Right. I remember this now. Make sure it's actually a building. Don't think it is. Yeah, it's because we're missing this step. This is a script that Cargo will run whenever we build, and it's like it's saying here, we need to copy that memory.x file into where the linker can find it at build time. Otherwise, it's just not going to pull in our memory map. So, like we can run through the program right now, just looking at it, code review, right? So it's going to figure out where the linker is going to be looking, and then it's going to open this memory.x file and write it to a file named memory.x in that output directory. And then it's going to tell Cargo to rerun if that file ever changes, and then it's also going to include that out directory in the search path for the rustc link. So yeah, we need all this stuff. So let me do this trick where I can copy the file over. I just drag it. There, now we have build.rs as well. And I should probably attribute this, right? Let's... Fighting my editor. But I will win. Okay, so this script is from the RP2040, what do they call it? Project template. Example. Provided or written by the RP-RS. The nice people of the RPRS project. Maybe give a link to their stuff. So that's this one. So let me just link that. There we go. Word rapid. Cool. So we can remember where it came from. Now let's build again. Oh, before I build, I don't think I actually needed that or that, right? I think that linked X provided by Cortex-M is all we really need. Flash. Nope. Okay. Pull that stuff back in, just in case. Okay, I'm still missing something. It's like what if we do a cargo clean? Just do a clean build. Hello, Endure Network. How are you doing? We sure pull in a lot of dependencies, including one called bare metal. It's sort of an oxymoron, right? If it's a library, then we're not on bare metal anymore. We're based on the library. Okay. Flash. Now still memory segment out of range. We have our build RS. We have our memory X. We have our regions here. What am I missing? Let's compare that to this. I mean, I guess I could pull in their linker. Maybe we'll have to depend on their linker, the flip link linker for now. Nope, that's not it either. I don't think I can change much else here. Wait. That length of memory range? There's not a whole lot of memory in this thing. The flash is pretty big, but we only have 256K of RAM to play with. Actually, it's 264K. I don't know why they specify only 256. Maybe 8K. The 8K. There's two 4K banks. Maybe they're not accessible by our normal programming until you map it or something. I think maybe we'll have to look into that later. Pretty sure we have 264 kilobytes of RAM to work with. Yeah, I don't know why it's not. Maybe it's not picking up our memory.x for some reason. To make sure, let's cause a syntax error. Now when it builds, it should not build. Okay, so it's obviously not pulling in my memory.x file. This should have pulled it in though. Sure enough, there's no memory.x file there. Actually, I'm not sure exactly which directory out is. Oh, CD to RP, that one. Is it build? Okay, let's just do a dir memory.x.
Beep, beep.
Sorry about that. My beep sound. What? This, oh, it deletes it when it's done. That's right. Okay, I forgot about that. We had it deleted it when it's done. I think in this build.rs, right? No, it doesn't. So it should be sitting there. And I don't understand. Let me hose this file to make sure it's actually using it. Okay, so it is parsing our build.rs file. But it's still not using our actual memory.x file, right? That's a better way to make it. That should make it not link. I don't get it. Unless one of these is wrong. But the way I understood it, this link.x is provided by Cortex-M, and then it includes our memory.x if it exists in the right folder. Okay, so I'm missing something. I'm missing something in the middle. More people's having issues starting Discord, can't seem to update itself. I don't know, are we having Discord issues right now? I did not have any trouble using Discord today. I don't think this matters because this is only when you do cargo run. I'm pulling all of these things. I have the same target. I don't think we need that. The only other thing I can think of is they are bringing in a crate by dependency. These are all optimizations, like a crate by dependency that we're not and we need to. Like, I'm not calling out Cortex-M directly. Maybe I need to. Yeah, let me try that. Let's pull in Cortex-M. Whoops. Let's pull in Cortex-M, even though we don't use it at all. Maybe we just need to have it there. Nope, that wasn't it. Something else here, embedded how. Anything else that's different? I don't have a readme or authors yet. Can't think of what's different other than I'm not explicit on what minor version we're pulling in. 075 instead of 073. I mean, I guess it could be explicit and see if that makes a difference. Could it be one of these? That's profiling. That shouldn't matter, right? The issue right now in Durant is that when we go to, sorry, I can build it, but when it tries to convert it, I mean, I'm on the wrong folder. When it tries to convert it to UF2, the format the bootloader will use, it finds a segment that the linker included in the wrong memory region. It included this segment in the build image, the firmware image, that doesn't map to anything. Because this is our memory map, right? Everything starts at a really high address. So the linker shouldn't have put anything there. So I don't know why the linker is producing something there. I guess we can look at it. Cargo, what's like cargo object dump? Is that the? I want to do that with release. I forget what it is. Which one of these is it? Just all? Beep 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 beep. Sorry about that. I'm already getting annoyed by my own beep sound that I made. Is it A? What is it? See, that cannot load memory.x parameter some. Yeah, it's the thing that includes memory.x is that link.x, which we're telling it to pull that in. So I don't know why the linker isn't accepting that. It's all headers is what it is. Or lowercase a. Wait, are there no symbols at all? Hold on, what's cargo size say? It's completely empty. That's our problem. Nothing's getting linked. Okay, why would nothing get linked? Because oh well, actually that there's something that makes sense about that, right? If it's not pulling in memory.x, it's not externing our entry point symbol, and that means this whole thing it's not pulling in any of this, not pulling in our entry point at all. Okay, then I must be missing some mechanism that they're using to pull in everything. So what could it be here? One of these uses? We have this, right? Yeah, there it is. What's different? They're pulling this def empty. I don't think this matters. This is just for making that that logging stuff. Yeah, it's mangled. Should I unmangle it? I'm in the wrong project. I could unmangle it and see. But wouldn't the linker give me an error? Maybe I'm wrong about that. Maybe the linker doesn't give me an error. No, it's still empty, even though I unmangled that. So it's something else that's missing that I'm not doing right. It's different here. Besides that. It's largely the same. pack is not pulled in for some reason. No, it is pulled in. Why am I pulling in pack? This is pulled in through HAL. Okay. That shouldn't make a difference. Their example pulled in pack through HAL instead of directly from the main crate. But that shouldn't make a difference. It didn't make a difference. Okay, what else is different? Should I just give up and use everything from their config toml file? Did these two linkers and we strip this linker? I thought I'm pulling in that linker now too. Okay, I'm just gonna give up and copy paste their entire cargo toml and use the same one. There, it's exactly the same now. So obviously something is different. I'd like to know what's different. Failed to parse crate metadata. What? Why? Do I need to... Maybe I need to clean it first. Why would it say can't parse crate metadata? Something here? We'll figure it out. What does that mean? Cargo Clippy. It's when I pulled this in, so what's different here? I don't know. Maybe it's just the size doesn't work now. Does build work? Oh, here we go. Can't find defmt.x. This didn't have defmt.x either. Where is defmt.x? Where can I search that? See, it's not here, right? So where, I know it's listed in here. So it's in one of our dependencies has that. I just don't get, like, what did I just change now that now it doesn't build? Oops. That key. Okay. Undo. Is it this comma here? Is that comma important? This is driving me nuts. It's not that. Okay. And now I have to go recopy it all. Actually, I don't really need to recopy it. Let me just copy one thing at a time until it happens. Okay, now, do we get something different? And that's not it. This stuff? I'm saving the best for last, the most likely candidate for last. So it really is this target config alt, this thing. This probe run. Why would that be important? It is important somehow, but why? This line probably doesn't matter, right? Is it this runner line? It's just having a... Oh, I see. Okay. Anybody else see the problem? This rust flags needs to be within the context of a target. That's the thing. Okay, that's what it was all along. We needed that target in there, and I don't know why we do that business. We should just do this. Target dot that, right? That's the problem. Okay. So now I need to figure out what dependency am I missing that pulls in def empty. I guess I can look for that. Oh, okay. That's for the formatting junk. Okay, let's just drop that line then. All right. Gosh. I think that defmt is that formatter for debugging that their template is using that I don't care about. Yeah, so now it's building. Let's see what size says. Okay, so now we actually have code. So let's go back to the build command and then flash. There we go. Now it's working. Look, it's blinking faster and it's purple. It's hard because I'm moving and it's not exactly easy for me. See, believe me, it's purple. It's the red and blue are flashing. Okay. Whew. Going crazy. Okay, so I just struggled for what? Maybe half an hour on the fact that I was missing that line there. Without that line, this is not within the context of any section and it was being completely ignored. So we don't need any of this garbage. Right? We don't need the flip blink. We probably don't need the end. We just need... I want to get bare bones working. This should just work, right? The default, the only thing we need is this link.x, which I'm pretty sure comes from Cortex-M, and that's the one that includes our memory.x. I can try to find that again. I found it when I was working on some hobby stuff last week. Flash. Oh, I had to put it in bootloader mode. You like my device connected sound? That's so that you don't hear the sound and think that it's your computer that has a USB thing being plugged in and plugged out. Okay, yeah, we don't need formatting yet. Oh, we don't need this line either, right? I just want to get to the minimal baseline. None of this other, like, extraneous stuff. We'll add that later as we need it. Flash. All sounds are muted. How is it that you hear me talking then? Oh, you're on... Yeah, okay, I get you. So you're not on a Windows machine, so if you heard the Windows USB connecting, you'd be like, oh, that must be Ryamu's computer. Okay. Man, that was frustrating. So I figured it out, right? So we need the memory map, and I can try to find out how we get from there to there, but it'll take me a minute to figure out where that is. So the minimum is that we say we're building for this target, and then for that target, we need to have this compiler flag to tell the linker to use that linker script, which Cortex-M provides, and that linker script includes our linker script, which provides our board-specific memory map and how to arrange where we put the boot loader. You have uncovered the bot command, Endorn. All right. So let me try to explain this missing link.x. Why is it we don't have a link.x file? Where is link.x? If I were to search for it, it'd probably be in Cortex-M, right? So if I do start anywhere and I go to, let me just find it off screen here really quick. In the cargo folder, right? Don't I have a Dart cargo folder somewhere? Yeah, okay. Can I not show that pane? Can't. Hold on. Okay, I can do that. I just don't want to show off all the other stuff on my hard drive. How do you follow rustations? Sideways, because that's how they move, right? Well, thank you, Andorn. No problem. I appreciate it. All right, so I think if we look into Cortex-M, we'll find it. Cortex-M. Sorry about the small font. Source. Okay, I can't remember where it is. Hold on, let's search for it with DuckDuckGo. So it's Cortex link.x Rust. Need the keywords. It's all about the keywords. Okay, it's in Cortex-M-RT. That's where it is. Right. So here we go. Make it bigger, please. All right. So in the Cortex-M-RT crate, which is one of our dependencies, right there, because we're on a Cortex-M processor, it takes care of this stuff, right? Which is very important. The memory layout of the program, right? The vector table so the device can boot properly. All the stuff that I would need to worry about if it was truly bare metal, which it's not, because we're based on these nice libraries that the RSRP or RPRS people made for us, right? And it provides this entry thing, which you saw me use in my main.rs here. It provides the exception handler if we wanted to have an exception handler, all this other stuff. So requirements, we need to have a memory.x. The crate expects the user to provide it. And, okay, are they going to show us how it's pulled in? So we're supposed to specify the memory layout and junk like that. What I'm hoping is that they tell us how it works. What if I search for a link? Beep beep. .x. There it is. Right. So there is a link.x. It's Cortex-M RT's linker script. It depends on that device.x. Okay, so let me go back to this and go up. Let's see if I can find it. I found it. It's this link.x.in. So let me just drag it into VS Code to show you. Yes, I trust it. Of course I trust it. So this is the link.x file that we get generated when we pull in that dependency, right? So it has this include memory.x. So it includes our memory.x file, which describes the layout of memory and says how to lay it out in the firmware build image, right? Where to put things in memory. Basically, put the bootloader in the boot to section, so make sure the bootloader starts at the correct address, and then everything else goes after that, right? So then they take care of all of the like bare metal stuff, where, you know, reset vector and all this junk. And there's, yeah, all the stuff that we really don't need to look at right now, but if you really want to, just look up bare metal stuff. So our memory.x gets pulled in by our dependency Cortex MRT's link script. Oh, see you, Roy Mustang FPS. Found 2 more link.x in the docs. You are correct, it did. Oh, so here they're explaining it. To actually build this program, you need to place a memory.x somewhere the linker can find it, and then link the program using the link.x. So we had to do that, right? We had to, in our config, we needed to say use link.x. Right. They're actually saying this is how you do it on the command line. So it's a little bit messy. We won't have to worry about it after today because we've buttoned up the messiness inside our config.toml. If I just close that and hide that and close that, don't have to worry about it. It's all magical from here on out. Hey, we have some people to ban. Let's do it. You are banned. What lang is this? This is Rust. That's a really loud name. Quote if T1 inting. Hello. Yeah, this is not only Rust, it is firmware, low-level Rust. We have no standard library, no operating system. This program here, which is blinking these LEDs, it's blinking the LED right there. All right, so I've established the bare minimum that we need to blink an LED on this microcontroller. Most of it is boilerplate that I'd like to move somewhere and never have to look at it again. We should comment this part of the boilerplate, right? So this part is get access to all the peripheral hardware. Peripheral resources. So peripherals basically means hardware resources that are outside of the CPU but still within the chip, right? So you have the CPU core, like the microprocessor and its registers and stuff that's built into it, and then surrounding it there are peripherals, so like system timer, the watchdog, the general purpose I/O ports so that you can drive individual pins, that kind of thing. What microcontroller is that? It is the Raspberry Pi Pico, the RP2040. And that's a great thing for me to add to my questions list. Below. Question 7 was... Okay. Can I copy your name easily? Yes, I can. Copy, paste. That name is large. What microcontroller is that? If I can type this correctly. Raspberry. I apologize for all my typing mistakes. I'm still getting used to the Colmac layout. So yeah, it's RP2040. I did type 1. I meant to type 1. Thank you, Romania Hate. Remember, this is the first stream for several months. I'm still rusty at rusty at this. Only an Atom's bot. You could make it 2, Endorn, Make my bot look more like Atom's bot. It's fine with me. Yeah, so one thing I'm trying to do in this new series is collect these questions. Actually, I want to make these into commands so that if anyone asks a common question everyone asks, we can just pull up the answer real quick with like bang 2 or bang 4 or something like that. Thank you for the charity pity laughs, by the way. Time to port the functionalities? Yeah, why not? All right. before I go tonight, I do want to try to button this stuff up like I was trying to do before. I want to put it out of mind, out of sight, out of mind in something called Boilerplate. It's too bad that we have to have Boilerplate. Boilerplate is just code that you need to have. It's minimum code. You don't really want to have it, but it's necessary because, you know, the world is an ugly place. It's not perfect. So to cross the gap between just what we care about, which is blink the LED, and the actual hardware, which needs all this setup, we have our boilerplate. So let's move that into a function out of the way called function, public function. I called it HAL boilerplate before, right? Let's call it HAL init. Let's call it init boilerplate. I like that term better. So it's boilerplate code that we need at initialization time. And just to make my life easier, I'm going to copy all the uses over to boilerplate and then just drop the ones we don't really need. So which ones do we not need? We don't need these ones with the yellow squigglies on them. So we delete them. All right, and then we, let's say, return the things we care about. I'll just keep it simple for now. Return the resources we care about. And we learned before that even though we don't directly need timer, delay borrows from it, right? So we'll probably need to return that timer. Oh, this isn't boilerplate. This was a convenience function I made, right? Let's pull that out. Yeah, I don't need that there. Okay, so timer, delay, and then the, let's just call this something better. Let's call this the Neopixel. And it has a specific type, right? This type. Let's actually give that a name. So type Neopixel equals that junk. We'll need to, whoop, I didn't mean to do that. We'll need to, I did it again. We'll need to import those things, those names. Okay. What does it not like about this one? Wait, trait objects. Oh, it needs the associated type. What's the associated type on this guy? How come it doesn't tell me here on the pop-up? Would it tell me if I turn on inlay hints? No. HAL 9000? No, hardware abstraction layer. Which is question number 3. Let's make this like an actual command. So now when I do 3, it's that. And let's alias com3 with HAL. Now try HAL. There we go. All right. Easy bot hacks. This type is really complicated. I haven't wrapped my brain around this countdown type yet. It's a trait, which means this thing is depending on a trait. What's the actual implementation? That's the problem. We need to know what the implementation is. What countdown did we give it? We gave it It's something that we gave it in this new function, I guess, right? Yes, this last thing. What was that? This thing. This countdown type. This specific one. Okay, this is from RP2040 HAL. Okay. Okay. Is it... Okay, I need to find out where it is actually exported from. Countdown. Where is it imported from, though? Oh, it's in the same file. Okay, so okay, so wherever that timer, okay, right here, then it's just countdown, right? It's not exported? Really? It's not public? It is public. Wait, then why couldn't I is it not re-imported then? They don't re-export it, I guess. Shoot. Can I write import? No, I want a concrete type. That's the problem. I want to tell it that, yeah, it's the countdown from our HAL, but I don't think this HAL actually re-exports countdown. It re-exports timer, but not the countdown thing. That sucks. Well, I guess we'll import it ourselves. They do it where? If we go to timer and... No, go to HAL. Where does timer imported from? From that timer, okay. And there... We're ending... Oh, okay, it's that weird thing where they rename things before they use them, right? Where is that stuff done? It's this thing. No. It's one of these. This stuff is so confusing to me when they do this rename stuff and then they do uses from it. Pub mod timer, right? If I follow that, it's actually in a different crate now. Oh, no, wait, hold on. I'm confused. It's the same crate. RP2040 HAL. Oh, it's this one that re-imports it. Okay. This way. All right. I see. So why didn't countdown work here? It doesn't work because it's not exported? Oh, it would be timer countdown. Right? Got it. Oh, and there's where it was. Oh, I need to be explicit here as like RP 2040 countdown. Because this is the trait and this is the implementation. There we go. I did it. Oh, no. It needs a lifetime. Right. So we'll just give it a lifetime. Tick timer, right? Okay. Turns out I didn't need these in the boilerplate. Okay. Happy with Rust? Yeah, actually pretty happy with it. Going back to C, that's fine. I use C at work. I think C is a fine language within the scope of the code in your .c files, but I start to get uncomfortable when I have to pull in headers, especially the way people pull in headers to do strange things. And then building, I've never really been comfortable with how C code is built, where you have to have there's like a dozen different build systems, and pick your poison, right? Do you use CMake? Do you use GNU Make? Do you do it with your own scripts? More than 50% of the grief I have at work is that the build system, and not the code. Okay, so I need the correct types here, right? This is going to return me a timer, a Neopixel, with some, can I just say, guess my lifetime there? And, what's the third thing? Oh, delay. Actually, delay was a different, it's not called the delay type, right? It is the countdown. So it's this thing. Let's see if I can just get rid of that lifetime. Nope, I can't do that. Is it want static? I'm not a master of lifetimes yet. It's the lifetime of this object. This is holding a borrow to that. I'm not sure how to specify that. Do I... Is this how we do it? I don't remember. But then, do I have to say, where timer outlives the... I forget the syntax of that. Is that how you do it? You won't be able to do that. The bar checker won't let a return value borrow from another return value. Oh, Sarian. No! So how am I going to do this then? Split my boilerplate up into two things? Make the timer go into the boilerplate, maybe? No, because timer pulls from pack and resets, or pack, and pack comes... Okay. I guess we can pass the pack in along with the timer. So move this line and this line out. Pass them in. So... something like... Then I don't need these lifetimes, right? Hold on, I have to go say goodnight to my son, so I will be right back, alright? I'm just gonna hide my cameras. Be right back. I just realized it's like after midnight here. Just pin it. I don't know how to pin stuff yet. Okay. So pack goes in. Peripherals. And then so does the timer. Still fighting my keyboard here and there. Actually, it doesn't need mutable access, does it? We established it's that type, right? No. Sorry, that's the delay is that. So that's just a timer. So we're not returning it then. We're not doing, so we're pulling this line out and this line out. Pack. Oh, I just need to import that. Import it from there. Oh, it needs a lifetime? Okay, so yes, so we need to define some lifetimes. And that's the lifetime there. Can't move out. Hold on. I didn't ask it to move out. Oh, do we need to pass it in and then back out again? Like this? So then pass it back out here. Is that how that works? Yeah, and then what's wrong with this line? Oh, just declare it as mutable. That's the wrong place to put it. There. It's not the type that's mutable, it's the variable. Okay, almost done. I didn't add that to the... Wait, what? What's wrong? Use of partially moved value? Oh, we can't do that. We can't pass it back out because it's had the PAO 0 moved out of it. That happened where? I don't even see where it was. Can move the oh yeah, you're right. But I think we're still gonna have a problem because we're not because this actually steals something out of the pack, right? So we can't return that pack. Do I even need to return it? Maybe it just gets consumed. Yeah, I think that it just gets consumed. We don't need the rest of it. Okay, so then what's wrong with this? It's just not used. We need to use it. So that's up here. Okay, we need the pack and we need the timer made first. Whoops, whoops. All right, pack and timer. So this is, what does this literally do? Creates a new timer. Based off of this guy. Which just controls the time and alarms. It's just like the system timer. Okay. Don't understand it completely yet, but let's just assume that we are set up the system timer. All right. Get the resources we need. Well, initialize the system and get the resources we need. So that's the Neopixel, which is currently called WS, and what was the other thing? Oh, the timer, the delay and timer, delay and WS equals. There we go. So get rid of all this stuff. I need to be able to mutate both of them. All right. Oh, really? Timer moved something out of the pack? Dang it. So I really can't decompose, I really can't split out the timer from the rest of the boilerplate then. So I don't really need to get the timer back. What if it just consumes it completely? No, but the thing we get back out borrows from it. Can I put it into an object? I guess I can do that, so... This is a bad place to put it, but we'll put it here for now. Struct... I don't know. Resources? System? Let's call it system. And in there we'll put our peripherals. Option, because it will start without one, and this thing. I don't like this. I don't know. I don't think I'm going to very uncomfortable territory for me for Rust. This one was delay. That's capital O, by the way. See, this is we can't do this because that's a borrow of something else within the structure. Yeah, I'm okay. I'm just gonna pull the plug on this. We'll undo everything in main.
Beep, beep.
No. Put back our boilerplate, get rid of all this stuff. I need to like wait until I'm got more energy and not tired and figure this out later. So no more mod boilerplate. Delete it.
Beep, beep.
Beep, beep. Okay, make sure this still builds. Flash it to make sure it loads. Okay, cool. I gotta call it here because it's getting late, and when I have more energy and less tiredness, I'll rethink how I can move this boilerplate stuff away, because I really want to reduce it to like, when I look at the main program, it's like setup and then do the thing, right? Setup should be like easily bundleable somewhere. The problem I ran into was this peripheral access crate stuff gets stolen from to make the timer, and then the timer gets borrowed from to make these delays. And those partially moved values are hard to pass in and out of functions for me. I'll have to figure that out later. But thanks for watching. I should be back. I'm going to try to make this a regular thing, like a Monday, Wednesday, Friday thing. So I'll try to be back on Wednesday to pick this up for stream 2. And I think the first thing I'll do on Wednesday is try to decide on like what are the areas of focus, because I got to get from this to something more like this, right? So we have to figure out a lot of things, like how is this microcontroller board going to be wired up to the keys? How are we going to detect key presses when we have two controllers, like one on the right and one on the left? How do they talk to each other through this cable in the middle? So that TRS stuff, the protocol between them. And the other things from my list. So maybe I just revisit that before I end. So a lot of the stuff is hardware based, but like it hints at the software support we'll need. We'll need the software for the data over the TRS cable, right? We'll need the software that is detecting the movement of these switches. Those are the fundamentals, right? And maybe that's where we start. I start from there. Maybe take this proto thing, which we can put 4 different keys on it, and actually wire it up to this controller and see if I can get it to detect button presses. Okay, so yeah, there's one more thing. The only interface we have with this thing right now is there's a button I can press, and then there's an LED we can flash. So before I do most other things, I'm going to have to include the software in this to use the USB. Right now, the USB is only used for power. I want to get the data flowing on that USB and get like either a terminal interface so I can print things out and see it, and maybe even the other direction too, so we can type and talk to that controller. Then I can actually, like when I hook up these buttons to it and we start hitting keys, we should have it translate to writing something out to our terminal, like you pressed key A, B, C, D, that kind of thing. So probably what I'm going to do on Wednesday then is, after kind of planning out what are the areas of focus, the next order of business for the software for this thing is figure out how to get the USB device working, maybe as a serial port, and then printing stuff back to our terminal. So that's probably what I'll do on Wednesday. But thank you for staying with me, and we'll be back in a couple days, okay? Have a good night. Oh, before I hit the stop button, I should check to see if there's something else going on Twitch. No, see, it's late on Monday night. I don't know anyone else who's streaming right now. It's so sad. I have no one I know that I could raid. Okay, well, I'm just going to hit the button then. See you, bye. Bye, 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 bye. Bye.